Okay, let's begin by looking at the second part of question 3, that is the B1. Here, in this, we have to identify the compound proposition, symbolize it, construct a truth table for it. So, three things we have to do. So, right, let it be here. So, three things. One is identify the proposition, same thing like the previous one. Identify the proposition. Second is symbolize it and construct truth table. So symbolize it and then truth table. This is also very simple. If you stay with me, you will be able to very easily score in this also. There's nothing to remember. This is all like a puzzle game. So identify the proposition, symbolize it, and create a truth table. Now what is the question? He is clever and he is either rich or lucky. Let's write it down. He is clever and he is either rich or lucky. I'll show you a very easy method of doing this. Just stay with me. Alright. So first thing is to identify. Identify the proposition type. We'll cover this later, identifying the proposition type. Let's first symbolize it. It is very simple. Okay, here also, let me gather my thoughts before I start. Okay, so what we do is first we underline clever, rich, lucky, and we have or, we have and. So these are all the things that we need to underline. Now C stands for capital clever, and stands for this symbol, or you can also write this symbol given in the book. I would prefer this symbol, so I will continue with this one. Rich is capital R, or is this symbol, or they write it like this also in the book. And lucky is for L. All should be in capital letters. All C, R and B, R and L should be in capital letters. Now, the way to write this is, we have to first see what two variables are joined, what two constants are joined. So these are constants, rich, lucky, clever. So rich and or lucky is joined. So as it is, we can also write first C and R, L, leave some spaces in between, or. So we have everything clever and rich or lucky. Now this has to be put in bracket because this is together. After the end, this is together. He is either rich or lucky. He is clever and, so he's clever and he is either rich, because the word either has come, therefore the bracket has to come. He is clever, this is how you read it. He is clever and he is either rich or lucky. So this is our symbolizing, that is, we have covered the symbolized part. It's a very simple symbolizing part. Now we'll take different variations of this and do conversions, like he is either rich but not lucky, or he is not lucky but rich, or he is rich but not clever, not lucky, and so on. We'll use different combinations to understand all different variations, permutations, combinations, and complete this also. Alright, so this is a very simple conversion of the statement into its symbolic format, or symbolizing it. Okay, now to cover the first part of our question on identifying the proposition. This is a compound proposition. So here in compound proposition, the identification is not as per A, E, I, O, the four type of propositions. This is based on the connective type, that is and, or, negation symbol, not, or implication, implies, or bidirectional, and so on. So we have to determine the dominant connectivity symbol. So in this case, we have, this is one part, this entire part is one part, and this is the another part. Now what is connecting both of them is the and symbol. This is conjunction, also known as conjunction symbol. So here the identity of the proposition would be conjunction proposition. Conjunction, because this is the most dominant connective. Or is the first or is, this or is solved, and thereafter only this and is applied. So therefore the proposition type in this is the conjunctive, and this is disjunctive, or conjunction and disjunction. So this is conjunction, this is disjunction. So I'll just type it out here. Conjunction, and this is disjunction, or conjunctive or disjunctive. We can write it that way also. Alright. So we did the first part, we did the second part. We'll also go through the identifying the proposition. What is the dominant connective type, whether it is and, or, and is conjunction, or is disjunction, this is negation, this is implies or implication, and this is bidirectional. This one is bidirectional. Alright, so we did the first two part. Now we have to create the third one, that is the truth table. Truth table is also very simple. There's a technique to that to create. So we have the statement in symbolized format. So to create a truth table, we'll need to symbolize it first. Okay, so we have, he is clever, and either he is rich or he is lucky. So now we have three variables, C, R, and L. So we create a table with C, R, L first, like this. Okay, we create a table like this. Now we have to create 8 rows. 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Alright, and 3 rows. Alright. Okay. So we start with, because there are 3 variables, we start with the, I'll show you the technique of easily doing it. So we start with true and true. That is, both R and L are true. Then we say R is true but L is false. Then we say R is false but L is true, and then both are false. So true, 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 false, false, true, and false and false. Same thing we have to repeat again. True, 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 false, false, true, and false, false. Okay, this first you write it down from the back side for the R and L, because we have to solve this first. Now for this side, for the C side, we write all 4 T's first, all trues and then all false. Okay, so now we have our truth table. TTT, TTF, TFT, TFF, FTT, FTF, FFT, FFF. Okay, so we have created our initial truth table. Now we have to create one more column. Okay, that column will be, that is, we have to solve this one first. This one first, that is R or L. This we have to solve first. That is, these two we have to solve. Now in the OR table, how it works is, let me explain. Down below I'll explain. See, for an OR table, if let's say one variable, this is P and this is Q. Okay, there are two variables, P or Q, and then we'll have separate for P and Q also. We'll solve both of them together. Okay, now sorry, excuse me. So for P or Q, what happens is, if any of them, so we have this truth table first, we write it down, false and true and true and true. Okay, sorry, false and false at the end. Okay, what happens is, in OR table, any of either P or Q is true, then the answer is in true. Okay, so we see here both P and Q are true, and we want only one of them to be true. It doesn't matter, even if one of them is true, the result will be true. So here P is true, therefore the answer is true, the result is true. Here Q is true, therefore the result is true, and here both are false, therefore result is false, because we want at least one true value for the result to come true. But for P and Q, how it works is, let us write it down, true, 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 false, false, true, and false, false. Okay, all right, just bear with my handwriting. So in this, both have to be true, both P and Q have to be true for the value to come true. So we have true here, this is the result. Okay, both have to be true. Here both are not true, therefore the result will be false. Here both are not true, therefore result will be false. Here both are false, so the result will be false only, because we want both to be true, then only the result will come true. So you understand how this is? OR and AND, this is how the table is. Have you understood this clearly? Then we can move forward. Or first you understand this table clearly. Take your time and understand this table. Okay, I'll move forward now. So we have OR here. OR means any one of them has to be true. Either R or L has to be true for the result to come true. So we see R is true, L is true, so the result will be true. Here also R is true, so automatically result will be true. Here L is true, so the result will be true. Here both are false. We need at least one to be true for the result to be true, therefore it is false. Here again it's true, 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 and then false. Okay, so now we got a value for R or L. R disjunction L. Okay, now we create another table. Now the table we'll be creating now will be for the entire symbolized form of the statement. So now we have C and R or L. Okay, now we have C here and we have R or L here. Okay, and we have the AND symbol. In the AND symbol I had mentioned earlier that both have to, that is, this part has to be true and this part has to be true, then only the result will come as true. Okay, both have to be true, that is C, R or L, both the columns have to be true for the result to be true. Okay, now we see C is true, R or L is also true, so therefore the result is true. Here true, true, so our result is true. This is true, this is also true, so the result is true. This is true, but this is false, so the result will be false because we want both sides to be true. Now this is false. Now all are false. False, 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 false. True, 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 false. So it doesn't matter. We need both sides to be true. So all results will be false only. Because we don't have true at both sides. Here also and here also. Here also both sides are not true. Here also both sides are not true. Here also both sides are not true. So therefore it is false. Only when both sides are true, then the result will be true. So this is how we create our truth table. So we have completed all three parts. 1, 2, 3. This can be very quickly created. So this is also for, this was for 3 marks. Okay, now let's take a variation of he is clever and he is either rich or lucky and create a different combinations and permutations. And this time I'll be going a little faster to save on time. So I've got 5 different statements for you here for us to solve. So we'll quickly solve them 1, 2, 3, 4 and 5. First what we'll do is we'll symbolize it, then we'll determine the dominant connective. So that will be the type of proposition in this. So the things we have to solve is, we have to solve first we have to symbolize it, then find the type of proposition, the dominant type, and then truth table. All right. Okay, so we have these 5 statements here and we have to first symbolize it, then state what type of proposition it is. In this second part we have to use the dominant connective to state its proposition type, and the third is to create the truth table. So we'll do it for each one of them as we go on. So stay with me. This will be again a very long video as I stated earlier. Alright, so first we'll take up is either clever or rich. Okay, so he's either clever or rich. Now how do we symbolize it? So first we highlight the key constants. So C is clever, capital C you have to write, R is rich, and L is lucky, capital L. Alright, now either, wherever there is either we have to put a bracket. Okay, or means disjunctive, this symbol you have to put and then close the bracket. And he is not lucky. So first you have to write he is lucky and then for not we have to use the tidal sign, or we can use a negation sign also. Both are valid. So for time being we can use this one. Alright, so we have already covered the symbolizing part. This we have done, the first part. Now we have to state which is the dominant of them. Alright, so the most dominant part is, first we have to solve this. So this is not a dominant part. Then we have to solve for the negation of L, that is lucky, not lucky. So this is also not a dominant part. So the most dominant part is the conjunction proposition. Conjunction will come in the final. So first we have to convert the lucky into not lucky, and then only it will apply. So the most dominant is the conjunction type. Alright. Now this is conjunction type. So let's say conjunction proposition. Okay, this is conjunction proposition, and the third was to create a truth table. For the truth table, I said we have to create 3 separate columns, C, R and L, as it is in the symbolizing format, CRL, and then we have to also solve this one first, C or R, the C disjunction R. We have to also solve for this type, that is negation of L. This also has to be solved, and then we'll be solving the entire one, that is C or R and not L. So this also will be solving. So we'll have to create 1, 2, 3, 4, 5 and 6 tables, 6 columns. Alright, so how do we do that? So first we write, as I mentioned, we first start with the 3 constants. So we write true, 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 false, false, true, false, false. Then we continue again. True, 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 false, false, true, and false, false. Again we repeat the same thing as we did for the first time, because the first 4 is for the true for the C, that is clever, and for the next 4 it is false. So basically we are covering all permutations and combinations of true and false. Okay. Alright, so once we are done with this, we move on to the next column. The next column is C or R. In C disjunction R, what I had stated earlier, if you remember, was that any one of them, either C or R, has to be true for the any one of them has to be true for the C disjunction R to be true, otherwise it will be false. So we see here both are true, so the answer will be true. Both are true, answer will be true. One is true, any one has to be true, so answer is true. One is true, answer is true. Here also true, true. This will be false because both are false here and both are false here, so this will be also false. So we are done with the column for C disjunction R. Now we have to negate the L. Now for negation, it is most simple of them. What you have to do is, this is the L. So if this is true, then this will be false. But if this is false, then this will be true. That is all we need to know for negating the L. That is negating the lucky, not lucky. So this is lucky, not lucky. So if lucky is true, not lucky is false. If lucky is false, not lucky is true. So true, false, false, true, true, false, false, this is false, and then this is true, this is true, this will be false, and this is false, so this will be true. Okay, let me remove the line from below that so it doesn't confuse. Okay, I will remove this line also. Okay, so we are done. Next we come to the complete symbolized form, which is if, not if, he is either clever or rich, and he is not lucky. So this is how you read this. Alright, so what you have to do is you have to take this one first, this part, and then use the conjunction with the second part, this part. Okay, so in the end, as I mentioned earlier, both have to be true for the result to be true, otherwise it will be false. Both have to be true this has to be true, this has to be true for the result to be true, that is the symbol to be true, their entire statement to be true. Now this is true but this is false, so the result will be false. Both are true, so the result will be true, otherwise it will be false. So this will be true because both are true, so this will be false again. Both are true, so this will be true, false and false, because we need both of them to be true. So this is what we have completed our truth table for this. That is all we need to do for he is either clever or rich and he is not lucky. Now let's take the next one. He is clever, then he is both rich and lucky. So let's break it up. First, if means implies he is clever, C, capital C, then he is both rich and lucky. And is this symbol, lucky is capital L, rich is capital R. Alright, so if he is clever, so this, if he is clever, this symbol will go away from here. If C is clever, this itself implies then he is both rich and lucky. He is both rich and lucky. It is not either rich and lucky and lucky. He is both rich and lucky. So this will be in the brackets. So this is the correct symbolic form of this statement. If he is clever, then he is both rich and lucky. Now, which is the major symbol or dominant symbol in this? So the dominant symbol is the implication type, implies. So this is known as implication proposition. So the type is implication type, implication proposition. Okay, so we got our second answer also. The first is symbol, how to symbolize it. Second is the type, and third is the truth table. So the truth table will be, again, we have three different constants here: clever, rich and lucky. So we create clever, rich and lucky, and then we have to solve this also. So we'll be using R and L, that is R conjunction L, and then finally we will have the entire thing. This will be one column, Okay, so we have, excuse me for adjusting the screen. Okay, so we have this symbol here. To see, first we write our normal truth table, TT, all variations of the truth table, TT, TF, FT and FF, and repeat that same again down below also. Alright, and in the first column we write all T's first, and then write all F false values. Okay, so this completes our initial truth table. All combinations and permutations of true and false for 3 different constants. Okay, now we need to solve the rich and lucky. So for rich and lucky, we need both of them to be true for the result to be true. So rich and lucky both have to be true. So this is true because both are true. Only one is true here. So the answer is false. Here also only one is true. So the answer is false. Here both are false. Of course it will be false. Here both are true. So the answer is true. Otherwise it will be all false, false and false. Okay. So we have completed the R conjunction L column. Now we move on to the entire symbolic form. So here we have to take the C, and that is, if I have to state, this is A column, B column, C column and D column. So we have to use the A and D column. Okay, and there is an implication symbol here. So now in implication, what is the truth value is that if, so for implication I'll have to explain in a separate window how the implication works. So let's say we have C implies D, for example. So we'll have to create C and D column, and then we have to create a separate column for C implies D. Okay, I'm breaking it up further to explain you how implication works in truth table. So we have only two constants, so there will be only 4 combinations: true true, true false, false true and false false. Okay, we will have only 4 combinations of true true, true false, false true, false false. Now in this, only if the first term is true and the second term is false, then only it will remain false, otherwise it's always true. The first has to be true, the second has to be false for the entire thing to be false. That is the conclusion. You can consider this as your premise and this as your conclusion. Okay, if the premise is true but if the conclusion is false, then the entire statement is false. But if premise is false and conclusion is also false, then it is of course true, because both it is true. Premise is false, conclusion is false, therefore the entire argument is false. It's true, the argument is false, so we say true, which is argument is false. If premise is true and the conclusion is true, then the entire argument is also true. But if the premise is true but conclusion is coming false, then the entire argument is false. If the premise is false, even then also if the conclusion comes true, then it is true. So this is the basic truth table. So what you have to remember is, only if the premise is true and the conclusion is false, then it becomes false. Okay, let's move back to this truth table here. So we have the C column, we have to take the C column and we have to take the D column and do an implication of this. Okay, so as I said, only if the premise, is true and the conclusion is false, then it's false. So we see here in the third row, premise is true, conclusion is false, therefore it is false here. Otherwise it is true. This is also true. This is also true. This is also true. True. Here the premise is true, conclusion is false, therefore it is false. And here it will be true. Okay, so we are done with the truth table here also in this. Okay, now next let's move on to the next statement. We did if he is clever then is both rich and lucky. Okay, so we'll cover the third one now. Okay, he is clever if and only if he is rich or lucky. So how do we symbolize this? Okay, so and would be this symbol or would be this symbol. Lucky will be L, rich will be R. He is clever, clever would be C. If and only if is represented by double-headed bidirectional arrow key. Okay, so we state he is clever if and only if he is clever if and only if. So there's no and symbol here. So instead of and symbol, it will be, the entire thing will be one bidirectional arrow. He is rich or lucky. So this will be the entire symbolic form. This will come here in nearby. So I can just erase this. My bad. Okay. So it will be bidirectional arrow. He is clever if and only if, this is how we read, if and only if he is rich or he is lucky. Now how do we, okay, so this is, now which out of this, what is the symbol we have already done? Now we have to determine the type of proposition. So this is biconditional, bidirectional, biconditional, because it is conditional. This is biconditional symbol. So the first we have to solve this, and then this will be the dominant type. So this will be biconditional proposition. Okay, this will be a biconditional proposition. Alright, third is the truth table. Once again, we have three constants, C, R and L. Okay, then we will have R disjunction L also, one column of that also. And then we'll have the entire bidirectional R or L. This way we'll create our truth table. Okay, now let us create the truth table as always we do. TT, TF, FT, FF. Okay, then again TT, TF, FT and FF. And here we'll write T, 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 T and F, 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 and F. Okay. Now we have created our three columns with the all permutation combinations of T and F, that is true and false. Now we have to do R or L, that is R disjunction L. R is rich, L is lucky. So we have to use these two. And we know for the disjunction any one of them is true, the conclusion is true. So if R is true, rich and lucky both, any one of them is true, then the result will be true. So rich is true, so we just write true directly. Lucky is true, we write true. Both are false, so it will be false. So it will be T, T, T and F. So we are done with the fourth column also. Now we use the bidirectional symbol. Now for bidirectional, what is the truth table? So I'll have to explain this again separately. So let me explain by two variables x and y, and what is their bidirectional truth table. Okay. So let us say this is, we'll have only four combinations possible because there are two constants here: true, 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 false, false, true, and false, false. Okay, so in this case, it is true only when both are true or both are false. That is all we need to know. This is both are true or both are false, then the concluding result or the argument will be true. Otherwise, it is false. That is all we need to know. If both are true, both the premises are true, then the conclusion is true. If any one of them is false, then the conclusion is false. But if both are false, then also it is true. So the thing to remember is, if both are false, then it is true. Now just to recap, in the implication proposition, what was the true value for implication? That is, if I have to create one more here, x implies y, what was the result? This we are just recapping now. We are memorizing what we had done earlier. So if it had not been bidirectional and if it had been implication, then only when the conclusion is false but the premise is true, then it becomes false. Otherwise, it is all true. This is the difference between the implication and biconditional. I hope this is clear. Now let's move back to our original table to complete this. So see, biconditional, either rich or lucky. So we have to use this column and this column. Now in bidirectional, I said if both are true, then it is true. If both are false, then it is true. Otherwise, it is false. So are both true? True, true. Yes, it is true. This is true. This is true. Yes, true. True, true. Correct. Then it is true. But if one is true and one is false, then the answer is the argument is false. This is false, so the result will be false. This is false, so the result will be false. This is false, so result will be false. Why it will be false? Because the other is true. Now this is false, but this is also false. Then the entire argument will be true. I hope you have understood the last part also, because I have explained here in the truth table for x biconditional y. It is true only when both are true or both are false. You see, it is true and true only when both are true or both are false. Otherwise, it is false only. So this completes our truth table for he is clever if and only if he is rich or lucky. Next, let us take the next one. It is not the case. Alright. It is not the case that he is both clever and lucky. Now, it is not the case. Not is a negation symbol. And he is both clever and lucky. It is not the case. Means if it was just like this, he is both clever and lucky, then this would only suffice. But when he's saying it is not the case, means he is not both clever and lucky. So we have to put negation here. So he is not clever and lucky. That is, he is both not clever and lucky. As I mentioned, we can also use this symbol for negation or this symbol also. But in our books, it is given as this symbol. So I'll not want to take a risk by putting the other symbol and continue with this one. So our symbolizing for the proposition, compound proposition is complete. First part. Second part is to determine the dominant part of this. So first, when we solve this internal one, C, clever and clever conjunction lucky, we come to the dominant part, which is negation. So here, negation proposition is the dominant. Negation proposition is the dominant proposition type here. Alright, so our second part is also completed. Now third part, we come to the truth table. So this truth table will be much simple. So we have to first do two columns here, C and L, and it will be only 4. So true, 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 false, false, true, and false, false. Alright. First we solve the C and L. C and L. Clever and lucky. So in end, we know that both have to be true for the argument to be true. So this is first premise, this second premise. Only when both are true, the argument or the conclusion will be true. So let's say true, true. So this will be true, and rest all will be false because both are not true. Here both are not true, both are not true. So this will be all false for the end, for the conjunction. Alright, now in the fourth column we will be negating this third column, C and L. Okay, we will be negating the C and L. So this is very simple. Negation I have already explained. If this is true, then this will be false. If this is false, this will be true. If this is false, it will be true. If this is false, it will be true. So the end result is this. This is the truth table. Negating. Okay. So we are done with the truth table as well. Let's go on to the next proposition type. All right. Okay. Nor means, well, first we'll type all the capital letters: rich, lucky, and clever. So we have three constants. Nor means or. It is equivalent to or. Neither. Neither rich nor lucky. Neither rich nor lucky. Both. If he is not clever, which is an implication symbol, then, if then. This is an implication one. If then. So, if he is, that is, we start with this. If he is not clever, then it means that he is neither rich or lucky, nor lucky. But here, if you see, here it means he is rich or lucky. So we have to negate this. Because we are saying not lucky. And not rich also. So it is both. It is applying to both. Not rich, not lucky. And here also, if he is not clever. So here we are saying he is clever. So we have to say he is not clever. If he is not clever, then it implies that he is neither rich nor lucky. Okay, so how do we create the truth table for this? So first we have symbolized it. Now what is the dominant type in this? So first we have to solve this inside, then we have to negate it. Then we have to solve this and negate it. And then the implication will be the last part where we have to complete the entire symbolic form in the truth table. So implication proposition would be the dominant type of proposition in this. So we say the type of proposition is implication proposition. Next, third is the truth table. For truth table, we'll have to first do C, R and L. First that. Then we have to do R disjunction L. And then we have to negate R disjunction L. And then we have to negate the C. And then the whole entire proposition will come, which is not C implies not R L, not R, not L. Okay, so we have this many tables. So we write our normal truth table T, TF, FT, FF. Again we start TT, TF, FT, FF. Okay, and here for the first column it will be all true values, true, 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 then false, false, false and false. Okay, so this completes our basic permutations and combinations of true and false values. Okay, now R or L, we need only for this two, we need only one true value. So we have one true value in this, in R, one true value in L, so it is true. We don't have true value, so it is false. True, true, true and false. This completes our fourth column also. Now we have to negate this fourth column. For the fifth one, this is the fifth column, so you have to negate it. We have to negate the fourth column. So if this is true, then this will become false, 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 true, false, 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 and true. Now we have to also negate C, that is clever, this one, first column. We have to negate this. So if this is true, then this will become false. This is true, this will become false. This is true, this will become false. This is true, this will become false. And we know the other four are false, so it will become true, 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 and true. All are true here. Okay. Now we use the 1, 2, 3, 4, 5, 6. So this is fifth and sixth we'll have to use to finally complete the seventh column. Okay. Now implication also we studied earlier. What was the implication table? Implication table stated that if the first part is true, but if the second part is false, then only the entire thing will be false. Otherwise it will be true, true, and true. That is, if both are false also, then also it will be true. But if the premise is false and the conclusion is true, then also the argument is true. But if both premise is true, conclusion is true, then also the argument is true. But if the premise is true, but the conclusion is false, then the entire argument is false. This is what it means. Implication. Alright. So what we have to do is we have to just detect the first is T and then F. Then it will become false. So TF means this is false. Do we see any other TF? No. So only one is false. So rest all are true. If both are false, it is true. False, true, true. If the premise is true, but the conclusion, sorry, if the premise is false, but the conclusion is true, then it will be true. True, true. And if both are true, of course, it will be true. So this completes our entire set of different combinations and permutations of determining, symbolizing, and creating truth table for different type of statements. So I have covered almost all 5 of them. This is the most easiest way I could have explained you. If you have still, I'm sure you have understood, but if you have still not understood, request you to go through this again. It's a very scoring question for 12 marks, 6 marks rather this one, and the 6th one the earlier one. This way 12 marks can be easily scored in this. This is more like a puzzle. If you take it as a puzzle, then you will enjoy this. And there's nothing to remember in this, just the technique, the system, the method, that is all. I hope this has helped you a lot. Let me continue with the next part. Take your time, go through this. This will hardly take 3 or 4 hours, but I think you will easily score 25 marks if you complete this 3-4 hours of video. Watch it 2-3 times if you are not understood, but I've made it as simple as I could. Let me know in the comment section also if this has helped you, because that will motivate me to create more videos, more easier videos, more better videos for you. Hold on for some time now.